Okay, hello everyone, welcome. I hope you all had a great weekend, great Halloween weekend last weekend. Couple of announcements, just making sure everybody kind of knows where we're at before we hop into the coding stuff for today. First off, the exam last week. We are almost done grading the exam. There's just a few things left that we need to take care of. It's looking like tomorrow is probably going to be the day that we'll be able to post those exam grades. Assuming that nothing else happens between now and then, I would expect to see those exam grades tomorrow. And then as far as the rest of the semester goes, we're kind of getting to the home stretch here. So we have 3 more weeks of new material left, which means we have 3 more quizzes left, which means we have 3 more studios left, and just 1 more exam. And that's it. That's those are the gradable things that we have left this semester. 3 studios, 3 quizzes, and technically 2 exams because there is a final exam as well. But we'll talk more about that as we get closer to exam time. So just kind of want to make sure that you're aware that we're kind of running up to the end of the semester here. The next 3 weeks, we're going to introduce those 3 new topics, as I mentioned. You may notice that on the 24th, we do still technically have class that day, but there's not really a whole lot here on the agenda. That's intentional. That's Thanksgiving break. That's the week of Thanksgiving break. So I know a lot of you probably have travel plans and things of that nature. So we are going to be available. I know at least I will be available on this day. I assume Professor Nuri will be available on Monday as well. But it's probably just going to be sort of an open office hours type day on that day. So you're welcome to plan your Thanksgiving week accordingly. And then, yeah, once we get back from Thanksgiving break, we're going to have our final exam review session and exam 3, which for many of you will hopefully be the last exam that you take, unless you choose to take the final. So, just want to make sure you're aware of what's left. If you know, now is definitely a great time to go over the grade book and make sure that everything's looking okay. Sometimes mistakes happen. Sometimes we don't get people marked on studios or things like that. Sometimes the quiz grades aren't copied in the grade book properly from Gradescope. These things do happen, so please take a moment, try and get those things fixed. Definitely, I can speak for myself and say that I'm a big. I like to get these things fixed sooner rather than later. The longer you sit on these problems, the bigger problems they become. So please, if you notice anything wrong with the grade book, reach out to myself or Professor Nuri so that we can get that taken care of as soon as possible. Are there any questions about logistics? What's coming up in the next few weeks before we switch gears and talk about today's coding topic? Any questions about what's coming up over the next month or so? Yeah, in the back. No, no, there's the calendar's accurate. We've pushed the quiz to be after Thanksgiving break. So, yeah, plan accordingly, please. Okay. I'm not seeing any further questions, which means we're going to go ahead and hop into today's topic. This is a big one. We have actually been working towards this moment basically since you walked in this door the very first day of class. This is not the finish line. We're actually just kind of still getting you started down your coding path for a lot of you, but certainly a milestone, certainly an important moment in your computer science career and your computer science education. So today we're going to be talking about objects. And we've actually kind of been using objects this whole time. We haven't necessarily told you we've been using objects. But in a language like Java, it's kind of hard not to. Java is based around this whole idea of things as objects. So let's talk for a second before we take a look at some code and see how we actually write these things. Let's talk about what we actually mean by objects. We've introduced you to various types such as int and double and string and things like that. And those are great for describing things, right? But we want to be able to describe more complex things on the computer. We want to be able to run simulations on anything, right? We want to be able to simulate anything we want to on the computer. And so some things just can't be represented by a number, by a single number or a single piece of text. Some things require multiple pieces of data all put together into one unit in order to function properly. And that's essentially what an object is. An object is a form of encapsulation, and that's a big fancy, $1 million word for combining multiple pieces of data together into one unit to represent a more complex, more sophisticated thing than just an integer or just a double that represents one number. The nice thing about objects is that within our code, objects, the objects that we create, the things that we are actually representing in our code, can be used as types. So that's something that goes all the way back to the very first week of class when we introduced you to those very basic types like ints and strings and doubles. We're now saying, well, those types aren't good enough. I want to make a new type. So when I generate a new kind of object, that is essentially what we are doing in our code, is we're generating a new type. And anywhere that we've used types in the past, such as defining variables, we can now use our new class. And I hope to show you that a little bit later on today. But for starters, what I would like to do is just kind of show you the anatomy of a class, work through the different parts of a class, talk about how it's kind of different to how we've coded up until this point. We are shifting gears quite a bit. Everything that we've done up until this semester is still going to be useful, but the way that we think about those tools is going to be a bit different after we insert objects into the equation today. And I also think it's important, too, to point out that object-oriented programming is the most common style of programming that exists in the world today. Not everybody does it with Java, right? C++ can also do object-oriented programming, and lots of people do object-oriented programming in C++. And other languages as well. Python can do object-oriented programming. I know a lot of you probably have already seen some Python, right? So this is not something that is unique to Java. These skills will translate to other languages as well. Knowing basic general object-oriented programming skills is, the bare minimum for getting most tech jobs in industry these days. That is just pretty much an essential. So with all of that preamble out of the way, let's take a look, starting with something that we've been kind of dancing around this entire semester. This line that I've highlighted right here, we are defining a class. A class is a template, right? A class is a way that we state what our object contains. We state what is going to be encapsulated inside of these particular objects. So in this particular case, I'm trying to create a class that represents a person. There are certain things that, all people have in common that we might wish to represent in this class, and we actually see some of them here. We see that in this class, our person object has a name and an email address and a phone number. There might be other things that you could think of that might be also suitable to include here as well, such as a birth date or height, right? Or eye color. These things also apply to an individual person. Why haven't they been included here? Well, for many applications, your eye color may not matter a whole lot. If it does, then that's something you may wish to choose to include in your class, right? But this is nice. This is flexibility. It allows us to decide what values are encapsulated inside of our object based on the program that we're trying to write. And this part looks familiar. These are actually variable declarations. We showed you variable declarations all the way back on the very first day of class. The different part has to do with this word private. We're going to talk about that a lot today as well. One thing to remember for now, though, is that for these instance variables that we're going to be talking about, all of them should be marked private. This is something you can write down, underline, put a star next to it. Other professors may have other opinions on this, but my personal opinion on this is all instance variables should be marked private, period, end of discussion. There should never be any instance variables not marked private. And I'm going to talk about why that is a little bit later on today in class as well. The other thing to notice about these variables, though, is where they are, right? Where they're being declared. They are not within a method. So before today, in order to create variables like this, we would have needed to do it inside of a method. We've been talking about methods for the last few weeks now. So we could have created these inside of the main method, or we could have created them inside of any other method that we wanted, right? But these we say are class level variables. They're created at the class level, which is useful to us, especially when we think about the scope of these variables. Can somebody remind me what scope refers to, or how we can view scope in our code? Yeah. Yeah, scope, that's a perfect definition. Scope is where within the code a variable can be accessed. So prior to today, scope was important to us because if we created a variable within a method, the scope says that I can only see that variable within the method where it is created. But think about what we're doing now. These aren't being created within the method, they're being created within the class. And so these can be seen throughout the entire class. These variables, these instance variables, have a wider scope. They can be seen not just in any single method, but all of the methods that are contained within the class. So that makes these very, very important variables. And I think it's also important to understand, that the choice of these variables is crucial. There are some things here that would not work, right, for a person class. So for example, if I tried to include an instance variable here for, oh gosh, I don't know, fins or flippers, right? Like that's clearly not people we're talking about anymore. Now we're talking about fish. If I tried to say that a person has, like a keyboard or a screen, well, that's not a person we're talking about anymore. Now we're talking about a TV or a computer, something like that, right? So clearly there are good instance variables that fit well within a class, and instance variables that aren't going to fit well within a class. And there's a relationship. I think it's important to understand the relationship between a class and the instance variables that it contains. These are has a relationship is what I would use to describe this. So I would say a person has a name, a person has an email address, a person has a phone number, a person has a flipper. No, that sounds weird. That doesn't make sense. That's a bad instance variable, right? A person has a screen. No, that doesn't make sense. That is not an appropriate instance variable. So I will quite literally say this either out loud or in my head, right? Just do the quick HAZA check whenever I'm writing a class, whenever I'm writing a code, and trying to decide on the instance variables that are contained within it. This HAZA check is very useful to just kind of do that sanity. Does this make sense as an instance variable? Does it belong somewhere else? And we're going to get some more practice doing that a little bit later on today as well. One other thing I like to point out, person. I like to relate this to parts of speech, right? It's called object-oriented programming. So all of our classes that we create should be nouns. They should be things, right? Sometimes they will be physical things that you can actually see. Like I can see myself, right? I can see people. Sometimes they will be abstract things, but nouns nonetheless that you can still see, such as games, have a lot of parts like that are invisible, perhaps, but still objects in their own right. But this needs to be a noun. The name of the class needs to be a noun. Should not be a verb. And also look at the instance variables. These instance variables are also nouns. So your instance variables should also be nouns. If you find yourself using verbs for your instance variables, that should be a red flag. That should be like, maybe this isn't an instance variable. Maybe this is something else. Maybe this isn't quite the place that it should go. So that's another quick check that you can use to determine whether your instance variables are in the right place or not. These instance variables, as I mentioned, are a crucial part of object-oriented programming. So, we're going to see these instance variables get used in most or all of the methods that are following. And so that actually is a good next step to talking about what a class contains. I've already covered one category of things that a class contains, which are instance variables. The second category of thing that I expect to find in a class are something we've already talked about quite a lot, methods. So methods aren't going anywhere, right? The two things that I expect to find in a class are instance variables and methods. Everything that I see within a class, within these two brackets, can fit into one of those two categories. Either it's an instance variable or it's a method. Those are the two kinds of things that go into classes. So instance variables are nouns. Instance variables are pieces of information about our class that help distinguish one version of that thing from another version, right? A person's name, email, and phone number helps you distinguish, me from Professor Nuri, because we have different names, we have different email addresses, we have different phone numbers, right? So that's what helps us distinguish one person from another, are these instance variables. The methods, that's going to be our behaviors. That's going to be our verbs. That's going to be the actions that our objects can take. And again, some of these might be simulations of actual things that people can perform, right? Running, jumping, kicking, right? All of those fun things. Or it might be more abstract stuff. It can be abstract things as well. Printing information, I believe, is one of them. But there's one method in particular that I'm going to spend a lot of time talking about today. It's such a crucial part of understanding and using objects. This is a method. It looks a little bit different from the methods that we've been working with before today, but it is in fact a method. We can see that it starts with the word public. The word static is gone. Actually, you'll notice that the word static seems to be kind of missing in general from this example and almost all of the examples today. And that's not an accident. We're going to be seeing that word static pop up less and less and less. And I'm going to explain more on that a little bit later on today. You can see that's on my topic of things to talk about today, as well as this idea of static things. So there is no static. There also is no return value here. It just skips what seems to be a big chunk of how we usually define methods. And then this is the name of the method. Notice that the name of the method is the same as the name of the class. That's also not a coincidence. That is very much intentional. And that is because this method is something that is known as a constructor. Something that is known as a constructor. The role of the constructor is to create a specific version of this class. So I'm defining a person. I'm saying that all persons have names and email addresses and phone numbers. And I'm saying that all persons can, print some information about themselves, right? But in order for me to actually use this class, I need to create a person. I need to not just have placeholders, right? These are just placeholders. I need to actually have a person with a name, a specific name assigned to it, and an email address and a phone number. And that is the role of the constructor. The role of the constructor is to make sure that all instance variables are properly set to some value. And the constructor is therefore creating what we call an instance of the class. That is an important vocab word that you're almost certainly going to be seeing on exam 3 in a few weeks. That word instance, right? Again, to reiterate what that is, this class is just a template. You can think of this class almost as like a blank form. So it has a blank for name, email, and phone number, right? When we call the constructor, we fill in the form. We say, I want a person with this name and this email address and this phone number, and then poof, that person now exists as an instance in our code. And we can then manipulate that person. We can have them do things, right? Based on what other code we have available in the class. I want to show that to you, actually. But real quick, some more stuff about the constructor, since it is so important, right? We're going to talk a lot about constructors today. But all constructors are defined this way. Public, skip the static, skip the return type, class name. Exactly the same name as the class. Exactly. While we're on the subject, while we're sort of on the related topic, class names, always capitalized. Always. Always capitalized. Lowercase, I think it'll let you do it lowercase, but it's a no-no. It's frowned upon. And also, you may have noticed this as well, the name of the file. Also same as the name of the class that it contains. Not a coincidence. Those are all very standardized things within Java that are generally expected, right? This constructor, you can see, accepts values from whoever calls this constructor and then sets them to the instance variable. So I take in the name, the email address, and the phone number as parameters, and then I store them into the instance variables. I have one assignment statement for each instance variable. I would argue that's required. Every single constructor needs to ensure that all of the instance variables are properly set to some value by the time the constructor is finished. A lot of times you'll get that value from reading in parameters, but that's not the only way to do it. I'll show you some other examples a little bit later on. Once we have this instance, once we have called the constructor and set these instance variables to their appropriate value, once we have the instance, we can then use methods, the other methods from the class. But the way that we use those methods is going to look a little bit different, again, from the way that we've been using methods before, because we have objects involved now, whereas before we were just using methods by themselves. So what I would like to do next is actually scroll down here to the bottom of this example and show you the main method. This right here is a very important line. This is going to call the constructor. So the constructor, again, is just a template saying how to create a new person object. But this line of code actually creates a new person object, actually creates a specific instance of a person. What person are we trying to represent? The one that has this name and this email address, right? And this phone number. In fact, I'd like to go one step farther and try to illustrate using my rudimentary drawing skills here, what actually this looks like on the computer, right, after you run the constructor. So the way that I typically do this, we're doing encapsulation. Objects are encapsulating variables. So I like to represent that by drawing a shape that represents my object. So this circle is the object that I'm creating. And then within that object, I'm going to see all three of these instance variables, name, email, and phone number, right? And those are going to have these values, sana@gmail.com. So I would literally, if I was trying to represent this on a sheet of paper during an exam perhaps, then I would literally, write these in. Ooh, can I get a bigger font though? Let's try something that y'all might actually be able to see, right? Name is Sana. Email and phone. I don't remember what the phone number is. It doesn't actually matter what the phone number is, right? Just trying to illustrate where this data goes. So when you call the constructor, and you create an instance, this is what we're creating. This is our object. This is the object that has been created. Let's focus then on this side of the equal sign for just a moment. What is this side of the equal sign doing? I know it might feel like a complicated question, but it's really not. It's not meant to be. Yeah. Making a new person, and then I'm looking for a word that starts with a V. If I said int x, I would be declaring a variable. How is that any different from saying person x is the point I'm trying to make, right? Where before, all we really had available to us were int and double. I'm telling you that, hey, when we create a person class, we're creating a whole new type. So anywhere that I used types before, I can now use person. If it was okay for me to use int there before, well, now I can make a person there if I wanted to, right? So this is creating a person variable. This is creating a variable called P1 that refers to an object. And actually, this is another word that's going to come up a lot over these last few weeks. This is what we would describe as a reference. to an object. So to fully understand what this is doing, let me update my illustration and show you how I would incorporate the left-hand side of this equal sign into this picture. I would do that by drawing an arrow, something like this. And then on the other side of that arrow, I see P1. So P1 is a variable. It's a sign pointing at this object. And within that object, I see the instance variables and the data that they contain. This is a specific instance of the person class being referred to as P1. So then if I take a look at the, oops, wrong window. Then if I take a look actually at this next line, I'm going to come back to the printing in just a second. But since we're on the topic of creating instances, right? This also creates an instance of an object. Hopefully you could kind of see how we would incorporate that instance of an object into our diagram. I'm creating another circle. And then within that circle, I have different instance variables. This time the name is Jean. I don't remember the other values. Jean at Gmail and a different phone number. Gotcha. Okay. The email is Jean at Gmail. Oops. And phone number is something else. And the variable that we've created to refer to this object is called P2. So just like I did for the first object, I would have some sort of arrow pointing at this. But this time the arrow is P2. This really helps me when I'm working with objects to kind of have this mental picture of how these objects exist in the computer as I'm going along. Especially because, you know, we're just doing the basic stuff right now. It does get a lot more complicated. You can certainly do a lot more complicated stuff with objects. So having a good mental picture of what these objects, how they exist, I think is important as we go through, especially when we need to do the other important thing, which is to call methods. So before, if I wanted to call a method, right, on the exam last week to call the method, all you really have to do is put the name of the method. That's not true anymore. If we're using objects, we now have to call the method upon an instance of an object, where, again, recall instances are what gets created by constructors. So what that means is in order for me to call this print method, you can see this print method exists here inside of the class. In order for me to use this, I can't just say print. I have to have a person. It is a person that is doing the printing. So I have to have a person object first, and then I can have that person object use the print method. Once I've created it, you can see that actually is represented in the code. When I call the print method, it's not just the name of the method by itself, it is p1.print, where p1 very clearly is a person, the one that we constructed on the line prior. If you just try to do print by itself, it's not going to work. And to understand why, consider that in order for print to work, it needs to have a name and an email address and a phone number. Well, those don't get assigned values until after we call the constructor and create an instance. So that is why we see this line creates the constructor first before calling the print method upon the instance using this dot notation, which we've already kind of seen before, right? But today is the day where we finally sit you down and are like, this is what's actually happening. It is instance dot method call. So what happens when we actually do this? What happens when we actually print? You know, we can run the code and see, but to think about what happens when we print this, consider the first time I'm printing P1. I'm telling P1 that I want to print. So the stuff that gets printed out is going to be the stuff that is found inside of P1, namely the stuff that's inside of this circle on our diagram, right? So if you're ever executing a method and thinking, what does name and email and phone number refer? Which name, email, phone number am I talking about? It is the one upon which the method is being called. So I would actually like to run this through in the debugger and show you this in more detail. I think that is a great way to hopefully understand a bit more about how this code is working. I set my breakpoint right here on line 26, the very first line of our main method, and now I'm going to start it up in the debugger. Okay, sure. And here we are. I haven't run the constructor yet. Has not been run yet, but as soon as I step over this line, take a look over here at my variables window on the left. You can see that I now have P1, and it's telling me P1 is a person. And if I expand this out, you'll actually see, oh, hey, look, there are my 3 instance variables with the values that are represented, that were passed in via the constructor to be stored in those instance variables, right? So that's pretty cool. And so then when I say P1.print, I'm going to use the step into button so that I can actually see the method, work my way through this method and see that, okay, we're printing stuff out. What is it going to use or what do I see over here? It's the same stuff as P1. And it's using a different word to refer to it. It's not using P1 anymore. It's using this. That's another important keyword that is definitely on our agenda to talk about today. But for now, I just want you to notice that, the values that get printed out are the values from P1. And as I step through, we see all those get printed out. But then I create a second person. When I call P2.print, it doesn't print out the stuff from P1, obviously. It prints out the stuff from P2. If you step into this method, you'll see that, okay, now I don't see the instance variables from P1, I see the instance variables from P2, meaning that this method is being used on the P2 instance this time around, not the P1. And we knew that because P2 is what shows up in front of the dot. I'm throwing a lot at you. I just strung a lot of pieces together, so I want to pause here and ask if there's any of that I need to repeat, if I need to go back over it again. This is a lot. It's kind of mind-bending. Yes. Yes, yeah, an object is an instance of a class. That is absolutely a great way to describe it. Absolutely. And a class defines the instance variables and behaviors of our objects, if we're thinking about it kind of in the reverse direction, right? Yeah, great way to summarize. Any other questions? Any of that you would like for me to go back and explain over again? I'd be more than happy to do. It's pretty crucial. Honestly, I'm probably going to explain it again anyway, just because we're going to get lots of practice with objects today. Okay. Let's talk more about constructors then, because constructors are so important when it comes to objects. Any object that I can conceivably, think of working with, I'm probably going to have at least one constructor for. And I think what's important to understand is that we actually don't need to have, we actually can have more than one constructor within a class, which is another kind of mind-bendy thing, right? What do you mean we can have more than one constructor in a class? How does that make any sense? Consider that a constructor, its job is to make sure that all of the instance variables are set. There's more than one way to do that. I'm about to show you 2 different ways to do that. So really, to create an instance, it doesn't matter to me how it gets created, right? Providing multiple constructors just provides multiple ways for me to create things, multiple ways for things to be instantiated, more ways for instances to be created. So in some programs, it might be beneficial for you, right? In some programs, you may not, you may wish for there to be multiple constructors. One common constructor that you'll see is one with no parameters. This is called the default constructor. What do I do if I don't know the values of any of the instance variables? Well, I'm going to pick one and just use it as my default pick. Right? I'll just say, if you don't tell me, so in this case, we're talking about cars, and the instance variables are the model and the year. If you don't tell me what kind of a car it is, though, I'm just going to make one for you, and it's going to be some, random car, right? But if you want me to make you a specific car, that represents the car that you drive, for example, I will provide you a different constructor that will allow you to do that. And so then when you create a car, it's up to you. Do I want to create this generic default car, or do I want to create a car that represents a specific car, the car that I'm driving, or the car that I'm testing, or the car that I care about? So let's take a look at these two constructors and actually write them. I want to write these constructors. There are two instance variables. That means that I expect to see two variable assignment statements in each of these constructors. I think that is a great, great, great thing to get your brain wrapped around, right? Especially on an exam. If I ask you to write a constructor, look at how many instance variables there are and figure out how to write a variable assignment statement for each one. That is the role of the constructor. That is the constructor's purpose in life. It has one job, and that is to make sure that the instance variables are set. So there's two ways that can happen. We've already actually seen the first way, which actually looks more kind of like this constructor down here, which is that the person creating the car has to tell me what the instance variables are. If you want me to make a car for you, I will, but you have to tell me what kind of car it is and when it was made. That's what this constructor represents here, right? Those constructors will have parameters, and those parameters must be supplied by whoever wants to make one of these things, right? You have to tell me. The way that we do this, again, is just a variable assignment statement with these instance variables. So we could say something like model is equal to initial model and year is equal to initial year. Notice the instance variable is on the left. The parameter that's coming in is on the right. So I'm taking the values coming in as parameters and I'm storing them in my instance variables. These instance variables, recall, the reason why that's valuable, these instance variables can be used throughout the entire class. So later on, if I use a different method, you can see that, oh, I can also refer to the instance variables there. Whatever values were stored there when this object got created, constructed, can now be used in these methods as well. That's object-oriented programming. That is why we do it, essentially. So we can use those variables across multiple methods. What if I don't have parameters? Or what if I just want to... There's another case where I would say that this is useful to do. What if I don't want the person to tell me what it is, but I just want it to be the same for everything that gets created? Right? So if I create... let's say that, I am representing cars, but obviously, let's say I work for Honda, for example, right? Obviously, the make of every car that I create is going to be Honda. I'm not going to ask you if it's a Toyota or a Ford. I'm just going to say it's a Honda every time. So it is entirely possible for me to not have the instance variables come in as parameters and just set them directly to some known value, some pre-decided default value. And so in this example, they suggest that we use this guy, which is the empty string. That's actually not my favorite, but default value to use. I would prefer to use almost anything besides the empty string. In fact, I might choose something a little different for the purposes of this example. I might say that the default model is going to be a DeLorean, because I watched Back to the Future the other day. And they didn't make DeLoreans in 2019, I'm pretty sure. So I'm going to deviate from... Oh, that's too old. I meant to say 1984. Pretty sure they did make them back then. So, my default... If you don't tell me what kind of car I'm going to make you one that can do time travel, Back to the Future style, right? That's what I've decided. For your program, you can make it a different car if you wanted to, right? You can make it your favorite car. That's your choice. But if you want to make a car that actually represents, the specific kind of car that you want, you need to use this constructor down here. There are just two different paths to do the same thing, which is to create an instance, and they both are going to get there the same way, which is by setting each instance variable to some value. It's just this one uses parameters, whereas this one uses default. Any questions on that before I actually scroll down to the bottom and do the next part of this exercise? So I'm going to create a couple of cars next, right? And I want to do it both ways. I want to create a default car and I want to create a more specific car using both of these constructors. Show you that at the end of the day, they both get me the same place, which is I will have an instance of a car class. So down here at the bottom, we can actually see it's been set up for us already. We want the first one to use the default constructor, regardless of what constructor I'm using. The first word after the equal sign. New, that's good, yes. Some of you noticed that on the prior examples, or maybe even from code that we've given you before. What constructor have we made you use before on previous assignments? Anybody remember? I'm sorry? There's one that starts with an S that we've made you use before. Scanner? You've definitely used the scanner constructor before. We didn't tell you that's what you were doing, but that's what you were doing, right? Anytime you use the scanner, you have to call the constructor. We've been sort of waving our hands over that part, but no longer. We don't have to wave our hands over it anymore. Now we can tell you, hey, scanner is an object, right? You created a scanner object and used it on your prior assignments. You already kind of know how to do that. Now we're creating our own objects. Now I'm not just going to create objects that Java gives to us. Now I'm going to say, here's an object that I want and create and use my own objects. That's really the power we're showing you today. All right, back to this example. If I'm going to use the constructor that I use just depends on the number of parameters that I give to it, right? If I give it no parameters, then it's going to do this one. If I give it 2 parameters, then it's going to do this one. If I give it 1 parameter, that's an error. I can't do that. That's not an option available to me. There is no constructor that only has 1 parameter. Do I want one? I mean, if I do, I can make it. That's my decision as a programmer, right? As we get closer and closer to the end of the semester, I really want to encourage you all to maybe kind of get out of your comfort zone a little bit more and realize that, hey, I get to decide what methods exist. I get to decide what constructors exist, how many constructors exist, and have the confidence to put them in if you think you need them and try them if you think you need them. But in this case, we only have the 2 available to us. So if I do a car with no values in parentheses, no parameters, then I'm going to get my DeLorean. If I do an example with 2 parameters, then I have to say what those are, but I can make whatever car I want. If I want to make a car that represents my car, it's I drive a oops, that's not a quote. I drive a Toyota Highlander. What year is it? I don't know. It's like a 2022, maybe something like that. Or, the car that I drove in school was a Volvo 240. That's the car that I drove back in college. I loved that thing. 1993. Great cars, built like tanks. They don't make them like that anymore. Yeah. So, what car do you want to represent? Choose the parameters and make the car that you want to represent. Regardless, it's the same story as before. If I want to call a method from the class, it is instance dot method call. So I have to call a method upon an instance of the class. But once you do, it will refer to that instance anytime that it needs to access the instance variables within that method. So just like we saw in the prior example, the first time we call print, it'll use the instance variables from car1. And the second time we call print, it'll use the instance variables from car2 to satisfy that method. Any questions on this before we hop over to our next topic? All right, great. Let's talk about accessors. I'm going to deviate a little bit from the script for this one, as I like to do. So here we have a class that represents a student. And again, this is what kind of relationship is it from a class to the instance variables? We'd say a student blank student has a name, student has an email address, student has an ID number. Okay. Earlier today, I said that all instance variables should be marked private. And I firmly believe this. If and when you're asked to create instance variables on the exam, they better all be marked private. The alternative to that would be to mark them public, right? So that's the alternative. And you might be wondering why. Why am I so, worried about marking these things private. What's wrong with marking them public? Well, let's work through a little example where I try to illustrate why that is so important to us. I'm going to make a new file. I'm going to make a new class. Um, Here we go. I'll call it, I'm just going to call it test.java. I need a main method. And within this little simple little test, I'm not going to do a whole lot here, but one thing I am going to do is I'm going to create a student. And I have to give that student a name. I used to go here actually. I'm an alum of WashU, so this maybe isn't true anymore, but used to be true at one point in time. I don't remember what my ID number was. It definitely wasn't one, but it is today. And so here we go. We have a student that represents, myself back when I was a grad student here 15 years ago or however long ago that was. Um, and this, as you can imagine, there are probably pieces of code in WashU's own system that represent yourself. And let's say somewhere on down the line, there's probably something that says, hey, I want to know this student's email address. What if I just wanted to access this student's email address and see what it is, right? That's something that's very important. If I need to email you all, for example, I need to get that email address out. One way that you might consider doing that is to access the email address instance variable that we know exists. So saying something like s.email doesn't seem unreasonable. S is the instance variable that we created. And inside of the student class, we can see that there is an instance variable that represents email, right? So saying s.email seems like maybe that would get us what we want. Maybe that will access the student's email address. And ultimately what I want to do is, print it out or something. Well, there's a problem. I mean, you can clearly see that. It's underlined in red. It's saying, hey, you can't do this. And the reason why it says I can't do this is it says the field student.email is not visible. The word field, by the way, I feel like it's important to point out, is another word for instance variable. So anytime you see that word field, instance variable, same thing, potato, potato. Just two different ways of saying the same thing. Okay, so, well, that's kind of a bummer, but this illustrates what it means for something to be private. What does it mean when we mark our instance variables private? That means that I can access this variable within this file, within this class. I can access it. But if I try to access this instance variable outside of this file, in a different class, I am not allowed to because it is private. So anywhere within this file, I can use this instance variable, no problem. But when I try to move to a different file and access it, I can't do it anymore. That seems limiting, right? What's the big deal about just seeing a person's email? I should be able to do that. And so you might be thinking, okay, why not just mark it public then? Clearly I have a problem with marking things public, but let's just do it and see what happens. And I can show you that, okay, I made this email instance variable public. And if I come back over here, oh, look, that error message went away. That seems like a good thing. And then if I print this out, you'll notice that, oh, hey, look, it actually even does what I wanted it to do. It prints out the email address. So what's the problem? It seems like marking things public made our lives easier. And actually, some people may even make that argument to you, that marking things public will make your lives easier. But there's another thing that we're not considering in this example, where marking things public has made our lives harder. Consider that if we make it public, things like this are now also allowed. Right? I need to put that in quotes, but you get the idea. Because this is marked public, not only can I see it, but I can also change it. I can also change that email address. And that's not something that happens very often, right? Once a student has an email address, you're pretty much locked in. Or if you think about it for an ID number, right? That's even more so. really, 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 really bad to change a student's ID number. That could cause all kinds of problems. We do not want that to happen. That is a big, big security problem to allow anybody to change. And public means anyone, right? Public means public. Public means anyone could change that piece of data. So this introduces us to data management, right? And every piece of data has two operations that can be performed on it. It can be read, it can be viewed, right? Or it can be written, it can be changed. Marking things public means that you can do both. You can read it and you can change it. Marking things private means you can't do any of them. You cannot read it, you cannot change it. Well, okay, what gives? There's got to be some middle ground, right? There's got to be a way that I can maybe do the reading part and not allow the changing part. And the good news is that yes, there is. There is a way to do that. The way to do that is not to mark things public. As I just showed, marking things public is very, 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 very risky, very bad form. If you're getting paid to code as a Java developer and you're marking instance variables public, that's a good way to have a meeting with your boss, right? About your coding skills. Be very much frowned upon. So how do we address this problem? How do we fix this? How do we work around this? I'm going to mark all of my instance variables private, and I'm going to use a different way to provide access to these instance variables. What's the other category of thing that I find in classes? There's two buckets of things I find in classes. One of them is instance variables, and the other one is methods. All right. So if I can't access the instance variable directly, I'm going to make a method that allows me to access the instance variable. And this is a specific kind of method. These are called accessor methods. There's two different types. They're commonly called getters and setters. The getters are used to view a value, view an instance variable. The setters are used to change a value, change an instance variable. This gives me more fine-grained control. Marking things as public gives me both viewing and editing. If I want one or the other, I mark it as private and then create the method that I need to provide either the getter access or the setter access or both. I can actually provide both that way as well. So let me show you how to do that. This follows a formula. The getters and setters all follow a formula. I'll show you the little formula for each. For a getter, it would be public. In this case, since the thing that I'm trying to access is a string, the return type of my getter would also be a string. If the thing I was trying to access was an int, then the return type would be an int, right? It has to match whatever the instance variable is that I'm trying to access. The name is almost always going to be get followed by the thing. So name get email would be the getter method for the email address, right? For getters, we don't have any parameters. And they're very simple one-liners. I'll just return email. Just return the instance variable that we care about. This solves our problem. This solves our arbitrary hypothetical problem that I made up earlier. If I come back here, if I want to see the email address, now I don't say s.email. I have to use the method. So I would say s. The name of that method that I just created is called get email, right? That was the method that I just wrote. So I'd say s.get email with the parentheses after it. And here, so you can see that this line is happy about. This line, still unhappy about. Cannot change it. Not allowed. It is marked private. So the getter allows me to see it. The instance variable is still marked private. I can't change it. Right? That's security right there. That is basic code security for us, working properly. I do want to show you a setter as well, because sometimes we do want to provide both reading and editing access to an instance variable. So if I wanted to make a setter for this particular instance variable, setters are always going to be void methods, and would almost always follow the format of set followed by the name of the thing that you want. This time we do need a parameter. So I'm going to say string new email. And just like we've seen in the constructor, I just take that parameter and store it to the instance variable that I care about. So I would say uh, email is equal to new email. And now if I wanted to use that setter, I would have to call it upon the instance that I wish to change the email of. So I'd say s.set email, and then I could, do jeff.bezos at Amazon if I wanted to. Oops. There we go. Right. So here's how we do a setter if we want to. But again, let me reiterate the point of these because sometimes students will get into a bad habit. I've seen it happen before, and I've done it before too, to be perfectly honest with you. I used to have this bad habit. I create a class, I make my instance variables, and then I just automatically create getters and setters for all of them. That is a bad habit to get into. Instead, I would encourage you to do this. Make a class, decide on your instance variables, and then move on to the next thing. Don't even think about the getters and setters. Once you get to a point in your code where you're like, oh, I can't go any farther until I have a getter for this instance variable, then create the getter, right? Wait until you have a demonstrated need to access that data. Don't just provide open access to it just because you can. That's risky, right? We're thinking about this from a security perspective, from a data integrity perspective now, right? So we can and should provide access to instance variables via getters and setters if the problem that we're trying to solve requires it. That is true, yes. But we should definitely wait until we are absolutely certain that it is necessary before we provide that access, because opening it up is a risk, especially the setters, reading, less of a risk, and getters are far more common than setters. I don't think that's an outrageous statement to make, but it's up to you as the programmer to decide whether the getters and setters are necessary. So keep that in mind when you're going through and designing your programs. Any more questions on that one, on the getters and setters? Actually, real quick, one other thing I want to show you. I did just write this getter and setter, and I think it's a good idea for you to practice doing that a couple times as well. But these days, if I'm writing code, these getters and setters, they're very formulaic, right? They all follow kind of the same format. So most of the time, I would actually allow the VS Code to do this for me, to generate the getters and setters for me, which actually, where is that option? I'm sure it's in here somewhere. Yeah, here we go. If you right-click on a class and go down to source action, one of the options that you're going to see here are generate getters and generate setters. Interestingly enough, there's also one for generate constructors. That one I would be a little bit more cautious about using, but also might be worth playing around with, since constructors also are kind of formulaic once you get used to using them. I think in all of these cases, though, definitely worthwhile to at least type a few out by hand first before you dive into using the tools, just so you fully understand all the pieces and how they connect and interact with each other. But this is a great time saver, right? Select the field you want to generate getters for. I want to create getters for these two. Boom, there they are. I don't feel bad about doing that. I do that all the time. Most professional programmers would say, writing getters and setters is like a tedious part of my job. So I'm going to let the computer do that part and focus on the more interesting stuff. And I agree. I agree, right? But when you're just getting started out, definitely practice a few on your own. I'm going to take I'm going to spend a few brief moments talking about static things before we have one final coding example to wrap up the day. So when it comes to static things, I want to make one thing clear to you. There is such a thing as static instance variables, but I want to say right now on the record that I have not tested over static instance variables in quite some time. and I don't plan to this semester either. So while there is some information in the textbook and in the examples about creating static instance variables that I think is useful in some contexts, that's not a heavy focus of this class, so I would not worry about that too much in terms of the exam. What I do think is worth talking about are static methods, because prior to today, every single method that you created started with public static. And today, every single method that I've looked at, with one very important exception, has not had that word static. So you can see none of these have that word static. Oh, wait, this one does. Well, that's kind of a special one, right? So in this class, for the remaining few weeks going forwards, we are not going to write static methods anymore. That is not a thing that we're going to do, with main being the one exception. We are definitely still going to be using the main method. That's sort of non-optional, right? Main has to be static. That's by definition. But all of the other methods that we write are not going to be static. So I think it's important to take a moment to explain what the difference is. Hopefully you've already kind of started to put the pieces together. It has to have something to do with objects, right? Because we weren't using objects before, and now we are using objects, and that's exactly it, actually. Um, oh no, don't do that. Sorry about that. Rude. Yep. Okay. I don't know why that happened, but while that comes back, um, non-static methods, the kinds that we've seen today, non-static methods. The reason that they're non-static is that they depend upon instance variables. They depend upon the instance variables in order to operate. Static methods do not use instance variables. That's the best, quickest, easiest way that I can draw the distinction between the two, right? Static methods, you do not have instance variables. You cannot use instance variables. It is not allowed to use instance variables within a static method. Non-static methods, we do use instance variables. And since what we care about in this class, for the last few weeks anyway, is objects and object-oriented programming, we are going to be using instance variables a lot, which means we are going to be doing non-static methods. In fact, I would go one step farther to say that in your programming career, from here on forward, the number of static methods that you write is small. I'm not going to say never. There is a time and a place to use static methods. Main, you'll always use. Other than main, still some occasions in which a static method might be the most appropriate thing to use. But in the vast majority of situations going forward, you are going to want non-static methods. You are going to want object-oriented programming, which uses instance variables. And if we're using instance variables, the methods must be non-static. To get a little bit more detailed about the difference, static methods are not called upon an instance. They're called upon a class. So a great example is math.random. Math.random is a static method. I did not have to call the math constructor, create an instance of the math class, and then call random, right? Math is the name of the class that that method belongs to. Random is a static method within that class. So static methods, I don't need a constructor. I don't need to do any of that stuff. I just call the method directly. Math.random. Done. Non-static methods, I have to have an instance upon which to call them. We've seen that many times today, right? I have to have an instance upon which to call them, which means that I have to call the constructor first. Make sure the instance variables are set, and then I call the method. That's object-oriented programming, which, again, is what we care about. So I'm not going to go through a whole lot of the static examples. What I just explained is what I care about when it comes to static versus non-static. I'm not going to ask you to write anything static again for the rest of the semester, with the possible exception of a main method. That's really it. So please keep that in mind going forward. Any last questions? I got one more example for you for the last 15 minutes. Any more questions before I switch to our last example? We're going to do a creative exercise for this last one. So this isn't one that was in the book. This is one that I like to do just because I think it's fun and a good creative exercise. Because as I mentioned earlier, you're getting to the point now where you're going to go out and start writing your own code. And me and Professor Nuri aren't going to be here to help you. You're going to have to make your own decisions, right? You're going to have to create your own classes. You're going to have to decide what goes in those classes and how to use those classes. That's where we're trying to get you. We're trying to get you to be not just people who know how to write code and use code, but confident programmers that can create code, design code, make good decisions. So I want to design a class and work through this process with you for the last part. This is actually very similar to what you're going to do in the studio on Wednesday as well, is we're going to give you a description of an object, and you're going to be asked to create code to represent that object. So the object that I want to talk to you about is one of my all-time favorite objects, a cat. We're going to create a cat class. Oops, I should have called it cat.java, but I forgot to add the Java. All right, I want to create a cat. I want to create a class that represents a cat. So we're going to start, as I generally like to do. Do I need a package declaration? Yeah, I need a package declaration. There we go. We're going to start with the instance variables. And again, remember, instance variables have a relationship. It has a relationship. So what I would like this is where I need your help, right? You don't even necessarily need to raise your hand. You can just kind of shout them out at me. What are some has-us? Cat has a what? Has a color I like. What else? Paws. What else? A name. Yeah, most of them do. That stray cat on my street is just, hey, you. What else? They have a tail. Sure. Any others? They have an age or a birth date? What's the difference? Let me suggest a couple. Cat has a voice. It sounds like something, right? A voice. Cat has fur. Most of them do. There actually are cats that don't, and you can Google it. I don't know that I would recommend you doing that, but they look really weird. But they do exist, and that's a thing. I prefer my cats to have fur, personally. One more that I'm probably not going to code up, but I want to think about just for a thought exercise. A cat has a mother or a father, both technically, right? But the reason why I add that one to the list is because the next thing to do is to decide, okay, what are the types of all of these, right? Because we eventually want these to become instance variables. So what we're looking for, these are good variable names, but what we now need are types. And then we also need that word private that's going to go in front of all of them. I don't know that I'm going to do all of these, right? I don't think I have time to make instance variables and code all these up, but I definitely want to code some of these up. So I would say, private string name. That seems like a good one, right? Private string voice. Seems like a good one. What would I do if I wanted to create one that represents the mother? What would the type of that be? I'm sorry? Boolean. Um, so, I'll just think about my own mom, for example. My mom is either true or false. How does that sound? I would pick true if I had to, but that doesn't really feel quite right either. What type should a cat's mother be? What type should my mother be? My mother is not a cat, but a human, a person, right? And I would expect a cat's mother to also be a cat? Whoa, wait a second. Is that too mind-bendy? It's okay if it is. But this is legit. This is good. This is a good thing, right? This gives us more flexibility. This gives us more descriptive power. right? Cats are now a thing that I can use in my code, and it knows what they mean. It knows what a cat is, right? I think that's a good thing. I'm not going to do that one today, but that is an example of why this is also important, why we like to do things this way, right? Um, we'll stick with name and voice for now because I know I'm running out of time and I don't have a whole lot of time to do stuff. The next thing that we need to do are behaviors. So these are going to become our methods, right? So what kinds of behaviors do cats have? What are the things that cats like to do? Help me out here. They sleep, they eat, they what is it? They make biscuits? Is that what it's called? When they get on you and they start doing this thing, they're kneading dough. Yeah, my cat likes to do that in the middle of the night when I'm sleeping. I don't like that so much. You would call that kneading? Those of you who don't have cats are like, what the hell is he talking about right now? But those of you with cats are like, oh yeah, that's the thing. Um, yeah, cats meow, right? It's a thing that cats do. I don't know about your cats, but my cats shed all over everything, right? Any verbs, any actions that you can think of, right, would be good examples of things that could go here. These are going to become our methods, but there's also one very, 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 very important method that I'm going to do for all of my classes. Starts with a C, and we've talked about it like a whole bunch today. A constructor. So regardless of what methods you have here, there's also going to be a constructor involved. And so with that in mind, let's do a constructor and see if I can have enough time to do at least one or two of these methods before we run out of time today. The constructor is always going to be public, but remember, no more static. Put static out of your mind. No return type for the constructor. We just put the name of the constructor, which must also be the same as the name of the class. Has to match. Now we have to decide on what the parameters are. Here, I'm actually going to add one more instance variable just because I can. Private int age. So I have three instance variables here, name, voice, and age. Check out what I want to do though. I'll read in the first two as parameters, which means that if you create a cat, you have to tell me what that cat's name is, and you have to tell me what that cat sounds like. But the third one, I'm not going to have as a parameter. So, I'll say name equals name, voice equals voice, age equals 0. So for my third instance variable, I'm just going to set it directly, which means that for every kit that gets created, right, you get to tell me what the name and the voice are, but their age is going to be 0. They're going to be a brand new, fresh baby kitten when you create them, no matter what. If you don't like that, you can change it. You can make another constructor. You can change this constructor. I just wanted to illustrate that you have that flexibility, right? You have the ability to take them in as parameters or set them directly. One other thing that I think is important to notice, take a look. These lines look a little weird. It says name equals name. Well, wait a second. I'm trying to take the parameter. What I'm trying to do is take this parameter and set it to this instance variable. But what's the problem? I have two variables, right? One of them is this parameter and one of them is the instance variable, and they have the same name. I gave two variables the same name. That's actually allowed. I can do that. The problem is that when I see this word name, it doesn't know which one I'm talking about. Am I talking about the instance variable or am I talking about the parameter? And if you make it choose, it's going to choose the closest one that it can find, which is the parameter. So this is not doing what I want it to do. It actually thinks that I'm assigning a variable to itself. I'm assigning the parameter to itself, which is useless. In order for me to make that distinction, I almost always will prefix my instance variables with another very, very important keyword called this. This. This is an important keyword, but it's also another one of those ones that can be hard to wrap your brain around. this represents the object upon which you are currently operating on, the instance upon which this method is working upon. So if I am in the constructor, this refers to the instance that I am currently creating, the one that I am now constructing. If I'm in a different method, right? So let me switch back to one of my prior examples. If I'm in a different method, I could actually say this.name. It's actually equivalent. I can take it off or I can put it on. We would actually say that it is implied. If I don't have it on here, it's implied. There's an implied this dot out in front. But regardless, wow, I cannot type that for some reason. Regardless, this refers to the instance upon which the method is being called. So if I am referring to, for example, s.getEmail, then this would refer to s, since that is the instance upon which I'm called. If I had a different instance of student called s2 or s3, and I called s2.getEmail, then for that method call, this would refer to s2 or whatever other instance is. So in general, the point I'm trying to make is that the instance on the left-hand side of the dot here, that is what this represents inside of a class. I know that's a tricky topic, though. I know that's a tricky one. It does come up, however. And then finally, just to kind of wrap things up, I do want to create at least one cat before I let y'all go here today, since I have 4 minutes left. Again, the type of the thing that I want to create is a cat, because I've defined a class called cat. So I am allowed to use cat as a type. So I can say cat, I have a cat named Lindsay at home, right? Is a new cat, and her name is, well, Lindsay. And Lindsay is a very chill cat. Lindsay's a very mew kind of a cat, right? And I have another cat at home called Franklin, and Franklin, obviously his name is also Franklin, but he's not a mew kind of a cat. He's a meow, meow kind of a cat. You know what I mean? Yeah, you know what I mean. And so, right, using these instance variables, we can use this object to create whatever kinds of cats we wish to represent. I wish we had more time. I would implement more of these methods, but hopefully you get the point, and you're going to get some practice doing this on your own on Wednesday. So have a good rest of your week, everybody. Professor Nuri and I will see you in the labs on Wednesday.